We are in Unit 11, and in this unit we're going to be solving trig equations. We're going to be using several different techniques to solve trig equations. Today we're starting out by solving trig equations graphically, and we are going to be using our graphing calculators for this technique. For AP Calculus, it is very important that you know how to use your calculator effectively to solve all sorts of equations. So what we're going to teach you today is something that you can absolutely take with you to AP Calculus. So first of all, know that all equations can be solved using graphing. Okay, so it is super important. Okay, so we are going to be using a calculator. Make sure your calculator is in radian mode. Hopefully you have the set of guided notes that you can fill out. It's available on Schoology. You can go copy it if you don't have the packet. Alright, and then we're going to use algebra to get 0 on one side of the equation, and then we will put that equation, that side of the equation, in for y1, and we're going to put 0 in for y2. This is the technique that I use. This is the one I like to use. I like to have 0 in for one of my my functions in the calculator. That way I know where it is all the time. I don't have to mess with the window as much. However, there is another way to do this, and that is not to move anything and just simply put the left side of the equation in for y1 and the right side in for y2. That is an option for you. However, if you do that, you will likely have to play with your window to find where these two graphs will intersect. If you have 0 in for one of the functions, then you always know where that is. That's just on the x-axis. Okay, next up we're going to set our window. And the directions for the problems will tell you what to use for the x max and the x min. So starts off with the x max, x min, and then it lets you enter the x max. For the x scale, well, before I talk about the scale, the directions tell you what. For most of our problems, we're going to be going from 0 to 2 pi, so we will put 0 in for the x min and 2 pi in for the x max. For the x scale, you might want to use pi over 2 or even sometimes pi over 4 when you're solving a trig equation. This just tells you how often there's going to be the little hash marks on the x-axis. Okay. So, and then for the y max and the y min, you just need to be sure that you include the 0. If you're like me and you set one side equal to 0, make sure that you include the 0. If you entered it the other way, you're going to need to play with your y max and your y min to see where the two equations intersect. Okay, and you can always change your window if you want to see the graph more clearly, more close up. If something's not clear from your current window, you might have to play with your window to see it better. Okay, all right, next up, how to state your answers. First of all, know that in trig equations, when you're solving a trig equation, there are an infinite number. Infinite. There are an infinite number of solutions to every trig equation. Because of the periodic nature of trig functions, when you're solving one of these, you're going to get an infinite number of them. So most of the time, the directions will tell you to find all solutions from 0 to 2 pi. However, it is important that you know that this is only the ones from 0 to 2 pi. There are actually many, many, many more. The solutions to the equations will be the x coordinate or coordinates of the intersection points. Okay, you are going to use the intersection key or the intersect key, found by pressing on your calculator. You're going to press Calc 5. This is on the TI-84. Okay. On the other calculators, you'll have to find out where the intersection key is. All right. You're going to round all answers to 3 places after the decimal point unless you're told otherwise. We're setting you up for what you're going to be doing in AP Calculus, and that is how they do it in AP Calculus. So 3 places after the decimal point. Your answer has to be correct to 3 places after the decimal point. All right? So don't round anything until the very end of your problem. Okay? If you need to do something with your answers because you don't want to round until the very end, if you have to do something with your final answers, you're going to use the stow, has a little arrow, the stow button on the home screen to store the X value into one of the letters, one of your alphabet letters. To get to the home screen from the graph screen, you're going to press second quit, and then you're going to press X, stow, and then whatever letter that you want to put it in, alpha A, alpha B, alpha C, whatever letter you choose to put it in. Okay? All right. Next up, let's look at some, before we look at examples. Okay, sometimes you need to type in a power of a trig function, okay? Or you might need to type in a reciprocal trig function. So let's talk about how you'll have to put that in. On your calculator, these TI-84s, can't speak for every other calculator, but on the TI-84s, you cannot type it in as cosine squared of your argument. Okay, it won't allow you. The calculator will not allow you to do that. Okay, so instead of that, we need to think of this as cosine of 7x all squared. It will need to be typed in as cosine of 7x parentheses, and then you're going to square the whole thing like that. These mean identical things anyway, so it makes sense on the calculator that it would have to be typed in like that. So this next one, if we were typing that in, the 3 is not being squared, so we leave it outside, and then parentheses, tangent, on your calculator, it will automatically give you this parentheses here. So this will just be 5x squared, close the parentheses on your argument, close the parentheses on your tangent, and then raise it to the 4th power. Okay? On the TI-84s, there is no secant button. So when you're typing it into the calculator, you need to think of that as 1 divided by cosine of x. Okay? So if you need to square secant, parentheses, 1 divided by cosine of that 4x that's there, close parentheses on your 4x, close parentheses on your 1 divided by cosine, and then raise it to that power. Okay? All right, now for some examples. Let's consider this equation. And first we're asked to sketch the graph. We're asked how many values of x in 0 to 2 pi satisfy the equation. And then we're going to list all the solutions to the equation in 0 to 2 pi. So in our calculator, let me get to where there's not a big glare. All right, so in our calculator, I'm going to go to my y equals screen, and I want to type in for y1, I'm going to type in 3 cosine of x squared minus sine of 2x. I like to pull everything onto one side, put that in for y1, and in for y2 I'm going to put what is now 0 on the right hand side. So this is going to be 3 cosine, and when we do pull up cosine, it automatically, we cannot avoid that parentheses there. It's automatically there. So when we, be careful with your parentheses here. Close the parentheses on the x, close the parentheses on the cosine, and then square it. Minus sine of 2x, close the parentheses on the 2x, and then in for y2, I just have the 0. Okay. Now for our window, right now I have it clearly, I had just put it on Zoom 4, which is my go-to window. But with trig functions, they tell us that we want to be between 0 and 2 pi. So for my x min, I'm going to put 0. For my x max, I'm going to type in 2, and then I'm going to pi, second pi. When I hit enter, it'll change that to a decimal. Okay, and then for my x scale, I like to see this on all the pi over 2's. So I put pi over 2, and when I hit enter, it gave me that decimal. For my y min and y max, I simply need to make sure that they include 0. So right now it's set on negative 4.1 to 4.1. That includes 0, so I'm just going to leave it like that. Again, you might have to go back and adjust that if you want to see everything more clearly or whatever, but regardless, we're always going to need to include that y value of 0. For my y scale, I just will keep it at 1. Okay, time to go graph, see what this thing looks like. And I see from my graph that I did not need to go all the way to negative 4.1 in my y's. I could have just gone from maybe 4 to negative 1, and I would have seen everything very clearly. So when we graph this, when we sketch the graph, I'm just going to give what it shows there. So it looks something like that. And I'm going to say that this is to 2 pi, 0 to 2 pi. Okay? All right. So I'm just going to use my little sketch for the rest of the problem. How many values of x satisfy the equation? Well, we're looking for how many times the curve is 0. And I can see it very clearly here. There are 4 times. 4 intersection points, 4 values of x in that interval that satisfy the equation. And now we're going to list all the equations. So now we're going to go back to our calculator, and we're actually going to find each of these. Okay? So I'm going to do, we need to go to the calc button. Calc button. So I'm going to do second trace, and that will give me the calc button, and then number 5 is the intersect button, so I'm just going to click 5, and I see it always puts you right in the center x value, but I'm going to come over here and get this one first. I like to get the lowest one first. I could move it along that curve, or you can go down arrow to jump to the other graph, the other equation, and it'll get you there a little bit faster. Enter, enter, enter. Okay, so that first x value is 0.9827 ... Okay. Since in this problem we just have to list the answers, I'm just going to come down here and list that answer. And I am going to round it to 3 decimal places, so 0.983. And then I'll go get the next one. So for the next one, again, second calc 5. Move over here, enter, 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 and we get 1.571. Rounding it to the 3 decimal places. I wanted to mention something here. Back on this other answer, well, shoot, now it is, I don't know if you remember, but last time we did it, it didn't give me exactly 0. It gave me something else. The next time I see that it does that, I want to explain something. Your calculator is using a numerical technique to find these intersections. And especially with trig functions, logs, exponentials, things like that, it's using a very, very good approximation or numerical technique. However, sometimes it will not show that just y equals 0 here. Sometimes it will show like y is equal to some number, and then it'll have e to the negative, or e negative 9, 8, something like that. What that means is it is extraordinarily close to 0, but just not exactly equal to 0. However, to 3 decimal places, this will be correct. So just keep that in mind. Okay, now I'm going to come find this intersection. So I jumped down there to the y equals 0 curve just to get there a little faster. And I get 4.124. Last one, we're going to go and get that intersection point. So second calc 5. Come over here and get that one. Enter, enter, enter. 4.712. Okay, so that gave me all 4 answers, and it just said to list the answers, so that's what we did. On some of the problems, we have to do different things with those answers. Okay. All right, number 2, consider this equation now. So I'm going to go to my calculator again. Try to get to where there's not a glare. Let me try to turn off this light. Yeah, that's better. Kind of. All right. Well, all right. Okay, so now I'm going to go to my calculator, clear out that function. I'm just going to leave that 0 in there because I know what I'm about to do. I'm going to type in the 2. So we have to cube sine. So I'm going to put parentheses, sine. The 4x is the argument. So close the parentheses on the 4x, close the parentheses on the sine, and then cube. Power of 3. I am going to get 0 on one side, so I'm going to subtract 3 cosine x, and I'm going to add 1. So that will be my left-hand side of the equation, and 0 will be on the right-hand side. Okay? And since I am keeping 0, my window isn't going to change. I'm just going to leave my window like that and graph it. And gosh, that's an interesting curve. That is a very interesting curve. I like it. So how many solutions are there? How many times does a curve cross or touch the x-axis? I do see 2 times there, 2 x values there, and I definitely see 1 x value here. My question is that, did it come down and touch right there? If you cannot see, there is a way we can figure that out. Gosh, there's so much glare there. Okay, there's a way we can figure that out. Under zoom, I'm going to hit zoom, and this zoom box, I'm going to click on that, and what that allows you to do is to go and push enter on the corners. So I'm right there, I'm going to hit enter, and it's going to set a corner of a box. And then I'm going to go down and over and set the other corner of the box. And when I do that, it'll automatically zoom in only on that box. So there it is close up. And clearly we are not touching the x-axis. So that will not be one of our solutions. Now, that really messed up my window, right? It's definitely going to mess up your window when you do that. So I'm going to quickly go back to 0 to 2 pi for my x's, negative 4.1 to 4.1 for my y's, and I'll get back to what I had before. But now I know that this is not one of our solutions. So how many solutions are there? 2 here, 3, 4. So there are 4 solutions total. And I'm just going to sketch this little graph down here just so I have something to look at and to write, for you to write your notes on. Figure out where to go here. So I'm just going to sketch this. Alright, it goes up. It never did hit, so I'm just going to exaggerate that. Something like that. So that just gives us something to look at. Something to mark up for the sake of your notes. So we have 1 solution here, 1 there, 1 here, and 1 here for a total of 4. And now what do we want to do? We want to find the sum of the 2 smallest solutions. So we're going to find this x value and this x value and add them together. So it is important not to round until your very final answer. So this is where we're going to be using that stow button. Okay? Okay, so here we go. Come over. Avoid your glare. Okay, I wish this was a little bit better. Let me turn off this. That doesn't really help. Okay. Alright, so second calc 5 to get your intersection point. I am going to jump down here to the y equals 0 equation, and I did that just by pushing the down arrow. I'm going to come over here really close to this one, enter, 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 and that gives me 0.333106, and I know that that's going to go on and on. I want to store that in for A. I want to store that in for A. So before I lose that value, gosh, this seems awfully dim. Before I lose that value, so right now your calculator thinks, that x is that number. But as soon as you go and find the other intersection point, your x value now is lost. So before we lose that x value, I'm going to go to my home screen, second, and then quit. Second, quit. Now you're on your home screen. So right now, if I push X, enter, that is that value. My calculator thinks that X is that value. But I don't want to lose it, so I'm going to take that X value and store it. The store button is right here. Push store. And then I need to get to one of my letters. So maybe like alpha A. If I get to the green, I'm going to do alpha and then the math button for A. And then enter. And so now every time I hit A, my calculator now thinks that A is that number. Okay? So that is stored now in for A. So now I'm going to go and get this next one, and I'm going to store that in for B. So go back to second calc, 5 for intersect, and we don't have to go too far to get to that next value. Enter, enter, enter. 0.479701, 0.4797105, ... and I am going to put that in for B. So let's go to our home screen, second quit, and do X stow B, alpha B. And now that value is stored in for B. If I hit B or do anything with B, it's going to use that value until I change B. Okay, so that's A and that's B. We want to find the sum of those two solutions. So A plus B is equal to A plus B is equal to 0.8128 ... We want to round that to 3 decimal places. So that will be 0.813. Okay? And that's how you store values. All right, last example. Consider the equation given by this. Okay, how many values of x in 0 to 2 pi satisfy the equation? So that's a pretty long one. We will put it in carefully. So I'm going to go to my y equals, clear what's there. 4 cosine of 3x, close parentheses on the 3x, plus 6 cosine of 2x, close parentheses on the 2x. I need to bring the 3 to the left, so it'll be a minus 3. I'm bringing sine x to the left, and that'll make it a plus sine x. And then I'm bringing cosine squared of 2x to the left. It'll be a minus, and then I want cosine squared of 2x, so parentheses, cosine of 2x, close parentheses on the 2x, close parentheses on the cosine, and then square. So you might want to look that equation over again, make sure you typed it in correctly. And our window is still set right, so I'm just going to hit graph. And I can see here that I am not seeing the entire curve. I don't know exactly what's happening down here. There might be another wiggle, I don't know. But I really don't care, because all we're looking for are the x values that satisfy this equation, which means I'm only looking for these values. How many are there? 4 again. 4 again. I'm going to sketch this graph to give us something to look at. And it looks something like that, possibly, where this is 2 pi and that's 0. So something like that. And I don't know what's happening here. Something's happening there. Okay? But I know it's not going to be one of my solutions, because the only solutions are right here. Okay? We want to find the product of the values of x in 0 to 2 pi that satisfy the equation. So we are going to need to get each of these, store them all into letters, and then multiply the letters together. So let's do that. This is x is equal to, second calc 5. I'm going to go up to my y equals 0 equation, move over there, enter, enter, enter. 0.536 dot dot dot. And I am going to put that in for A. So before you lose that, go to your home screen, second quit. I'm just going to clear that out just so it's on just this problem. X stow A, and there that is. Now I'm going to go back to my intersect feature and go get this next 0. Enter, enter, enter. 2.243 dot dot dot. And I am going to put that in for B. So go to your home screen, second quit. X stow B. Now that's in there. Go to our next 0, so second calc 5. Enter, enter, enter. 2.672. Dot, dot, dot. That's going to equal C. Whoops. Okay, before I lose that, second quit, X stow C. And then we'll go get our last one, second calc 5. Move up to the y equals 0 again. Enter, enter, enter. 5.794 dot dot dot. I'm going to put that in for D. So quit x stow alpha D. So now I have all of my values stored in for A, B, C, and D. If I want the product of those values, it'll just be A times B times C times D. So A times B times C times D. And that gives us 18.630 if we round it to just 3 decimal places. Okay. Before I leave here, I want to show you something. If I had rounded first, if we had rounded to 3 decimal places each time and then found the product, let's see what we would have gotten. So we would have had 0.536 times 2.244 times 5.795 times, oops, I missed one, times 2.672. That would have gotten us 18.624 if we rounded to 3 decimal places, which is not correct. So if you had written that, you would not have gotten credit for your answer. Okay? Because the correct answer, your answer has to be accurate to 3 decimal places. So do not round these. Do not round these. Use your stow button, store the whole thing in, and then multiply A, B, C, and D together. Okay, that's it for the lesson on using your calculator to solve trig equations graphically.